in this lesson, we'll be studying integral application and mostly net change theorem and average value of function problems dealing with position, velocity, and acceleration. So let's have a look at net change theorem. It's also called the fundamental theorem of calculus. Right, so what this says is that the integral from a to b, right, of f prime x dx is basically equals to f of b minus f of a. Right, this is similar to what we have done before. Remember when we are doing antiderivatives and or areas, we're saying integral from a to b of f of x, small f of x become bigger f of x, all right? It's similar to what we have done before. And that is equal to capital F of x, basically f of b minus f of a, right? So now, remember what I said, the derivative f of x and capital F prime x is the same thing, right, in this case. So you can remember it in either form, is good enough. The main thing is that you have to integrate over these boundaries. In other words, you're finding the antiderivative, substituting the upper boundary, minusing the lower boundary, and this gives you the net change, right? Okay, now if that gives you the net change, then we can talk about a position, right? So you have the position function. Basically, let's not work with the position function because the next one is equation of motion. I'll do that. Right, so remember to find the position, we can just integrate the velocity, integral of a to b, right? In other words, distance traveled, displacement, sorry, a to b of v of t dt. This will give you the net change, right? But this will give you the net displacement. In other words, it will give you the displacement because you are integrating a velocity function. So basically how far it has traveled from A to B, right? That's the total. In other words, the net change, the displacement. Remember, displacement can be positive or negative. We're not calculating distance. Distance will be a different scenario. If you're calculating distance, then you have to put absolute value. Okay, that's fine. Let's
Wait,
move
sorry,
on to the
mister, you
next.
said if we're calculating distance, it's the absolute
Yeah,
value of the same thing, right?
absolute value of not the entire thing, the absolute value of the velocity function. Note, if you're calculating distance, travel, then it can be integral from A to B, absolute value of V of t dt is going to be like that. Okay.
Okay.
And there are rules to follow here because you need to think about the x-intercept changing directions. And because remember the area under the velocity time graph gives displacement. And if you want to calculate the distance, then it's the actual path, right? Like the odometer reading on your car, right? So basically that's what you're looking at. We'll do an example based on that because you have to look at the intercepts. Right, next one, equation of motion. So we know S of t displacement, right? Or distance. Now we can't say distance because it's a loose term, right? Is basically S of t, right? Then we got velocity. In other words, over here we're looking at speed. That's v of t. And you know v of t is v prime t. Now, if you want to go back, obviously, if you want to go back from here to there, then you got to integrate. So if you want to find S of t, You're gonna integrate the velocity. Okay. Oh, sorry. It's S prime t, not V prime. V of t is S prime t, the derivative. So if you go from there to there, you need to integrate the displacement. Okay. Plus obviously S naught. What was the initial displacement? Okay. If you want the full function. Are we good, guys?
Yeah.
Next one. The acceleration.
Mr. This one we're saying that like velocity can be either positive or negative, but speed is only positive. It's like scalar
Yeah,
and vector,
speed is
right?
only positive.
Okay.
Yeah,
Same
scalar,
with
vector
displacement and
quantity.
distance, right? Distance can only be positive.
Yes.
Okay.
Let's look at acceleration. Acceleration will be V A of t, which is V prime t, and V prime t is the same thing saying S double prime t, right? And if you want to go from acceleration to velocity, you know what to do. You're going to integrate that, right? So now you're going to say V of t is equal to integral of S double prime. Okay. And plus V naught, whatever the initial velocity was, because if you want a full V function, we coming there, right? That's it.
Mr.
So yes,
Does that mean if we want to go from S W prime t to acceleration, we'd have to take the double integral?
no, you don't do double integrate. Integrate once, then integrate the entire function again.
Oh,
It's not
because
double. We're not.
sometimes I see values of like two integrals beside each other.
No. We are only doing a single variable calculus. We're not doing double variable. We're not
Oh,
doing double integrals. All right.
okay.
Right. So great. So those are your formulas. Next one. If you consider average value of function is a special function, average value of function, which is equals to integral, take the net change a to b of f of x dx, right? And we say 1 over b minus a. So we're basically integrating it, the integral over 1 over b minus a. That's what an average value of function is. Are we good, guys? Now,
Yes.
if you're thinking about this, what does this represent? We can have a look at what this here represent in terms of curves, in terms of a function. Assume that you have a function for average value of function. Just say if you have an exponential function, e to the power x, right? This is e to the power x function. And I'm integrating between the boundaries. That function is e to the power x. And I want to integrate between 0 to this point here, just say 0 to 5, right? So my average value of function will be integral 0 to 5 of e to the power x dx and 1 over 5 outside because 1 over 5 minus 0. Now think about this b minus a. B minus a represents the width of the rectangle, isn't? At the bottom. Okay, and this here represents the area, isn't? This here represents the area under the curve, and this here represents the width. You're taking the area under the curve and dividing by the width. Are we good, guys? So you're kind of getting like an average height. Okay, so this here is kind of like an average height. What happens if you take the area of a rectangle and you divide it by the width? What will you get? You will get height, correct? Let me draw a rectangle here for you. Right, you got the width and you got the height. If you take the area, which is the integral area under the function, and you divide it by the width, what you'll get? Height. But now you can't call it a height, you call it an average height. The height is average. Okay?
Wait, so
I
Mr.
mean,
when we're saying average value of a function, it means the average height, right? From one point to the next.
the entire value is kind of like an average height. Yes.
Okay. So in
Okay.
this case, it would be like, okay, I got you.
No. This here
It
is
would be whatever this integral is divided by
yeah,
5, right?
yeah. Of
Okay.
course. So this basically means you will get the area of this and the area of, see, this basically means because you're making the height average, you can make like a perfect rectangle instead of going and drawing this area under the curve over here. Okay. Okay, just for example, let's do this example here. What is the area under this curve here? The shaded portion. What's the area of the shaded portion here? The area will be integral of e to the power x is e to the power x. So you got 1/5 e to the power 5 minus e to the power 0, right? Because integral of e to the power x is just e to the power x. I substituted 5. Right, so now you're getting 1/5 e to the power 5 minus 1. That's your, can someone tell me what this value is on the calculator quickly?
Mr.
Mr. The bottom.
So the stuff inside
29.4.
is 147.4.
What you getting? 147.4?
Yeah.
No,
No,
mister.
everything.
Divided by
The
5.
full
Now we need to
thing
divide by
is
5.
29.4.
Yeah, 29 point, almost 5, 29.5.
Yeah,
Okay, good.
29.5.
And what's the total area here? 147?
147.4.
Okay, got you. Basically the area is 147.4, right? So this is 147.4, and the answer is this. So basically what we are saying is that if you try to make it into a perfect rectangle, you'll get W, which is 5, and the height is 29.5. The average height. Does that make sense? So now if you take the average height multiplied by 5, you'll get the perfect rectangle. Okay?
Okay.
So basically you are deforming this shape over here because this is, see, this bottom is a nice length, but look at the way it's curving over here. If you try to compress it, you'll get an average height, which is 29.5. Okay? Because remember, when you do a Riemann sum, you got multiple rectangles, isn't it? So now, because you have multiple rectangles, now we want to know, because you have infinite rectangles in a Riemann sum, we want to know, hey, wait a minute, why don't we just make an average height, okay? Why don't we just get like a constant height for a rectangle instead of having so many? Right, so that's what the average value of function represents, okay? You remember all these infinite rectangles that we fit. Obviously, if you try to fit a rectangle towards the end, you're going to get something bigger. So we're trying to get an average height, so which is somewhere around here. Right, that's what I've done here. Right, so anyways, let's go to the problem, guys. I only have 5 examples to solve, and then we are done. Right, so a particle moves along the x-axis with velocity v of t. And now look at the velocity function. It's a quadratic, all right? 8 meters per second, where t is measured in seconds. At time t is equal to 5, is a particle moving to the left or to the right? Now, obviously, if the velocity is positive, it moves to the right. If it's negative, it will move to the left, right? Provided that, remember, we're doing linear motion, all right? Not doing curved motion and stuff. So We are going to substitute 5 inside here. So to solve A, you're going to say V of 5. If you substitute 5 here, you will get, what do you get? That's 25 minus 30. You get 3 meters per second. So it's moving to the right. Okay. If it's negative, it will move to the left. Okay. Next one. Find the acceleration of the particle. T is equal to 4 seconds. So how do we find acceleration from?
We differentiate the velocity and then we substitute 4.
So let's find V prime. A is equal to V prime T.
2T minus 6.
V prime T, which is 2T minus 6. Now we're going to substitute 4 inside.
Yeah, so 2. Yeah, the answer would be 2.
V prime 4 is going to be 2 meters per second squared.
Yes.
Okay. And find the acceleration, include units. So 2 meters per second squared. Is a particle speeding up? Is the particle speeding up or slowing down? Now, very good question. Speeding up and slowing down. Let me explain this.
Mister, it will be speeding up. Why? Because if velocity and acceleration are in the same direction, then the velocity is speeding up.
Yes, good. So if V is positive and acceleration is positive, then it will be speeding up. Not necessarily positive, in the same direction, speeding up. Or you can also have V, it must be simultaneously, all right? It can also be V is less than 0 and A is less than 0, or V less than 0 and A less than 0. In other words, they are in the same direction, okay? Both are positive or both are negative, then it will be speeding up. If they are of opposite sign, then it will be if opposite signs, then slowing down, okay? Now, let's look at C. Now, what's the reason for that? What's the reason for that? We can look at something that's concavity, all right? We can talk about this. And we're looking at V and A. Just say this is the velocity time graph, okay? Right. Now you can see velocity is, okay, we're talking about velocity being positive and negative, right? So let's just say, let's bring it down here as well, right? Right, so velocity time graph, V is positive and A is positive. So now we're looking at V is positive here, right? Positive means above the x-axis. And it's positive here. I'm talking about V being positive. It's negative here and negative here. Now, when you're talking about acceleration, you need to look at the increase, okay? So, in other words, what is A of t? A is basically where the velocity is increasing. The velocity is increasing going upwards here, right? So, let's just put some values, 0 to 5 or 0 to 2. 4, 5, and 7. Let's put some random random values, right? Now, from 0 to 2, what's happening? What's happening from 0 to 2?
It's increasing.
Right, so it's speeding up, okay? It is speeding. What's happening from 2 to 4?
Decreasing.
It is slowing down. Don't say decreasing.
Yeah, it's slowing down.
Slowing down because because remember the concavity, wait, hold on. It is speeding up from there to there, then this is still positive, and the acceleration
Acceleration is,
now negative. Yes,
yeah, but it's still
acceleration.
less than the velocity.
Yes. Wait 1 second. A is V prime, isn't? So V
Yeah.
prime is negative. Yeah. So V prime, this is decreasing. So this is slowing down. Good. And now what's happening below the x-axis here? It is down. So this is speeding up, but
But it's
it's in the
speeding
opposite
up.
direction. It changed direction
Yeah.
here, right?
Yes.
So this is speeding, right? And now what's happening from 5 to 7?
Slowing down.
Is it slowing down because it's
Yeah.
negative and
Because
positive? Yeah,
on
slowing.
the
Good.
y-axis it's, yeah.
Yeah, slowing down.
But Mr. Why is it in this shape, the graph?
No, I just put any
Oh,
shape
okay. Okay.
for you to understand. All right.
Yeah.
Obviously, it's not. And it can be in the shape because this is like changing direction. Below the x-axis means it U-turned. It's
Yeah.
going in the opposite direction. So it's possible. Right, so anyways, we still need to answer C. Is the particle speeding up or slowing down? So we had V of 4. What was V of 4? V of 4 was 2 meters. No, we didn't calculate V of 4. We calculated V of 5. V of 4 will be 6 times 4 is 24, right? Plus 8 minus 16 plus 16 is 0. V of 4 is 0, right? And A of 4 is equal to, what's A of 4?
So it was 2 meters per
It
second
is a
squared.
2 meters per second squared. No,
So
but
it's
the
speeding up.
velocity being 0 means the velocity being 0, it means it is stationary.
Yeah, but then acceleration is being added to it.
Yeah, so basically you're changing direction and then you're speeding up, correct?
Yeah,
It's like something happening here,
right in the
isn't?
middle. Yeah.
Yeah, so we can say it's like velocity is 0, but this is obviously we can't say anything, but this one is positive. We can say changing direction and then speeding up. Is it changing direction and then speeding up? Okay, make sense? Are we good?
Yeah.
All right,
Wait, Mr.
excellent,
Is it
guys.
okay if I say the object accelerates from rest or it's speeding up from rest?
Yeah, whoa, wait 1 second. Yeah, you can say that as well. Yeah.
Right? Okay.
No, but what about the time being 4 seconds? Yeah, you are
Maybe it
right,
was
actually.
constant at rest
Yeah.
until 4
I wouldn't say
seconds.
changing direction because that's kind of like ambiguous. I would just say speeding up.
Okay.
Loose term speeding up, right?
Yeah.
Because if this was positive, then it would have been definitely speeding up. But now because it is 0, you have like multiple scenarios. So you can say exactly what you have said. You can say that. All right, we good? Next one. Find the total distance traveled by the particle during the first 5 seconds. What are we given here? We are given velocity. We want to find the total distance traveled. Okay. Now, very important question. We want what? Not displacement. What did they say? Distance.
Distance, so
Absolute
integral
value.
of absolute value of VT. Okay.
Yes. So D, very important. D is equal to not S of t, just say distance. Distance is equal to integral A to B V of t absolute value dt. Now we need to look at the V of t function and try to sketch it. And I'm telling you now, and I'm emphasizing, you must try to go and sketch easy function. This is a very easy function to sketch. If you sketch it, then you will understand exactly what's happening on the graph. Right. So what's V of t function? T squared minus 6t plus 8. T squared minus 6t plus 8, okay. I can factor this out. That's t minus 4, t minus 2. So I know I have x-intercepts, right? My graph starts at 8, right? And I need to see 2 and 4. It cuts at 2 and 4 as well. And remember, this is time, dealing with time, so time can't be negative. Of course, it can go below the x-axis, right? All right, so it is starting from 8, right? Because this is v and that's t. It's starting at 8, and you got x-intercepts at 2 and 4, right? At 2 and 4, you got x-intercepts. I don't care where it's turning. That's not important. I'm just going to put the graph like this, okay? Obviously, it's turning in between. It's probably turning at 3, right? And that's what your velocity time graph looks like. Now, we want to find the displacement from 0 to 5, okay? We want from 0 to 5. 0 to 5 is everything under this graph. Watch. Split up into 3 different integrals. It's going to be everything under this graph, everything under this graph, and you're going to go to 5 here, and everything under this graph, because we want distance. If you wanted displacement, you just integrate this function over 0 to 5. You get a net change, okay? So distance is now equal to integral from 0 to 2 of v of t. Remember, there's a v function. That's a v function. That's a v function. So 0 to 2 of what? What's the v function here? T squared minus 6t plus 8, okay? Dt plus 2 to 4 of what? 2 to 4 of the same thing, but absolute valued, okay?
Yes, because it has to be
Because
positive.
we're on the positive. Yes, 2 to 4 of the same thing. T squared minus 6t plus 8, because you're going to end up with a negative answer here. Absolute valued, right? And plus the third integral, which is 4 to 5. Integral from 4 to 5 of t squared minus 6t plus 8 dt. Now, it's very important that you know how to solve this. You don't go and integrate every single thing all at once. What we're going to do is find the s of t function, right, from here. S of t function is t squared minus 6t plus 8. Hey, we're integrating, sorry. Finding the antiderivative here. Okay, it's fine. I'll just do it inside here, the 3 different integrals. That's t cubed over 3 minus 6 t squared over 2 plus 8t from 0 to 2. Plus, I'm not going to integrate this again now. You already know the integral of this, which is t cubed over 3, still absolute valued, minus 3t squared, minus 6 divided by 2, plus 8t. And that's from 2 to 4. Plus t cubed over 3 minus 3t squared plus 8t. And that's from 4 to 5. And that's how you're going to evaluate this, right? I'm just going to use a calculator to evaluate this, right? And because I don't want to waste time on the algebra, so integral from 0 to 2 of the first function, which is t squared alpha x squared minus 6 alpha
I'll solve for
x.
the second function, okay, mister? So you can't waste time.
No need, because I can just change the boundaries, it's fine.
Oh,
That's 20 over 3, right? And remember, the next one is absolute valued. So obviously I will get a negative answer. So I'm just going to change from 2 to 4 here now. Two to 4, see, I will get a negative answer. I need to absolute values. So plus 4 over 3. Right? And the last one is from 4 to 5. And I'm getting 4 over 3 as well. Okay. So nice. Everything is in terms of divide by 3. So you will get
Should be
28 over 3. All right.
28 over 3, yes.
Yeah. Meters. Right. So that's your answer. So this is the actual distance traveled. Now, remember, I didn't ask for displacement. If you know work out displacement, right? Then that's going to be S of t, right? That's just going to be S. This is distance. If you know work out displacement, then you just integrate from 0 to 5 and you're done. No need to do anything. Displacement would have been 0 to 5, right? 20 over 3, right? That would have been the, because you can see this is 4 over 3 and that would have, those areas would have canceled out. You get a net area 20 over 3, right? So displacement is equal to just integral 0 to 5 of v of t dt, which is equals to 20 over 3 meters. Yeah, that's displacement, but we wanted the distance answer. That's the one we want. Right, so great. Let's move on to the next question. The acceleration of a hovercraft along a straight line is given by, right? So we have an acceleration function, right? Which is the double derivative of the position function, right? And is from 0 to 5, right? At time t equals 0, the hovercraft's velocity is v of 0, which is 18 meters per second, and position is this. Find the velocity function. So A, to find the velocity function, v of t, we just need to integrate this, right? But is v naught plus integral 0 to t of a of t dt. I need to change the variable here. Can't call it a of t, so call it like a of x, because I'm putting t there. I'll tell you why, because what's v naught? Initial velocity is 18, all right? Plus integral 0 to t of what is a of t. Remember, you want the velocity function, not the net. All right, so let's see, 0 to t of a of x, so 6x minus 12 dx. That's 18 plus, integrating that will give you 6x squared divided by 2, which is 3x squared minus 12x from 0 to t. If you substitute t here, that's it. You'll only get a function in terms of t. So that's 3t squared minus 12t plus 18. Oh, I would have done it like this. V of t, I would have written down a of t and just found the antiderivative. A of t is 6t minus 12. The antiderivative would be v of t, which is 6t squared divided by 2 minus 12t plus big constant. Now you need to solve for the constant because v of 0 is given. V of 0 is equal to 18. Right, v of 0 is equal to 18. So you solve for the constant. V of 0 is equal to, what is this? 0 minus 0 plus c is equal to 18. So the value of c is 18. Put it back into the original function. And then now you got v of t, which is 3t squared minus 12t plus 18. Got the same answer. Okay.
Mister, 80% of the FRQ questions were like this, in this form.
Nice.
Wallah, Mister,
Excellent.
last
So at least
year,
now you know two ways that you can have an easier method to solve.
no, last year out of the
Yeah.
6 FRQ questions, 5 of them were like this, and one of them was like discs and washerway. Very difficult, that one.
Great. All right. So now, guys, you have an answer here. So remember, I'm using the initial condition to solve this. It's like solving a differential equation, easy stuff, but basics of differential equation. Let's look at the next one. Find the total displacement. Keyword displacement, right? So not distance. Total displacement of the hovercraft from t equals 1 to 4, right? So from t is equal to 1 to 4, we only want from 1 to 4, right? So b, we want to integrate the velocity function. So s of, we're just going to call it s, right? Which means it is the displacement which is equals from 1 to 4 of this function here, which is 3t squared minus 12t plus 18 dt. You're integrating the velocity, right? And now you can just get the answer. You use your calculator, otherwise 3 t cubed divided by 3 minus 12t squared divided by 2 plus 18t. We're integrating, right? Add 1 to the power, divide by the same power, right? I'm just going to put it on the calculator, right? You can figure that out. There's algebra involved there. What we have, t cubed, x cubed minus 6x squared. That's going to be 12 divided by 2, 6x, right? Squared. That's 18t alpha x. And you're going from 1 to 4. Okay, so I'm getting 291 over 4. I can put that in decimal values, 72.75 meters, or what is it? Meters, yeah. Are we good, guys? Making sense?
Yeah.
That's easy. Let's look at the third question. At what time t in the interval 0 to 5 is a hovercraft furthest from the starting point? At what time t in the interval 0 to 5 is it furthest from the starting point? So do we need to look at the position here? How will we solve this? We didn't even use s of 0 is equal to 10. So I think we have to use find the position particle first. We have to find the position. So C. Look at part C of the problem. At what time t in the interval? Remember, we didn't use s of 0 is equal to 10 as yet. So we need to find the position function. Let's look at v of t, which is 3t squared minus 12t plus 18. We need to integrate this function to find the position function. So remember, it's just s naught plus integral 0 to t. Right, I wouldn't use this formula. I'd rather write down v of t and then integrate v of t to find s of t, okay? So now if you are using the formula, then you have to convert it to x, right? So v of t gives me s of t,
Mister,
which is, yeah.
why do this? Why can't you just say that since the position it's like increasing for the whole time, that means the farthest position from the starting point would just be t equals 5.
What is increasing?
The
How you
function
know this?
itself.
How you know this function is
Because you
increasing
said
always?
because you said vt is greater than 0 for all of the t function as well as the acceleration. So doesn't that just mean that the function
No.
will keep
Well, I
increasing?
said when the v of t is positive and when acceleration is positive, then it is speeding up.
Yeah, what I'm saying is that you can is it we integrated for velocity, right? We integrated for it. We got 3t squared minus 12t plus 18.
We
If
integrated the
we
acceleration,
Yes,
we
we
got
integrated
velocity,
for acceleration. And
right?
that gave us that vt is greater than 0 for all the values of t. So that
Wait,
means
wait, wait, wait.
velocity.
Hold on. 1 second, 1 second. How you know v of t is greater than 0 for all the values of t? That's what I want to know. That is an
Because
incorrect
Mr.
conjecture.
After that, if you want to factor it out, you would get 3 bracket t squared minus 4t plus 6, which will then give us 3 bracket t minus 2 squared plus 2. If you solve for 0, like if you were to substitute any value inside, we would get all of it from 0 to 5 to be greater than 0.
Is it always positive?
Yes,
Sure.
yes.
Okay, I didn't check that. You can also check it with the b squared minus 4ac with the discriminant to check whether if it's always going to be like that. But that's one of the ideas that you have, but I'm not too convinced because look at this function 3t squared minus 12t because when you
Factor it out,
factorize it,
Mister.
okay, I will factor. Let me get the position function first, right? So remember the value for c will just be the initial value, which is 10. So s of t is basically equals to t cubed minus 6t squared. How we got 6t squared? 12 divided by 2 is 6, all right? And it's t squared, adding 1 to the power, dividing by the same power, plus 18t plus 10. Right, so what Mesa is saying that if we try to factor this out, he's saying this is always positive. Let's check if his theory is correct. Is this function always positive? That's what he's saying. From 1 to 5 or 0 to
Factor it
5.
out. We'd get
You're going to
3
factor it out.
bracket 3 bracket t squared minus 4t plus 6.
And then
And
you can
then you
factor
want,
this out again.
yeah, the middle part, it would be, wait, let me check my notebook. It would be t minus 2 squared plus 2. Bracket t minus 2 squared.
3 into t minus 2.
Squared plus 2.
Yeah, because this can be broken up into plus 4 plus, right? So basically this is what he's saying. Now this is always positive, even if you substitute any value, yeah. So it is always positive. You could have also used the discriminant and said b squared minus 4ac. The discriminant is b squared minus 4ac to check that up. B squared is 12 squared minus 12 squared minus 4. A is 3 and C is 18. And that is negative. So it's not going to have any x-intercepts. And the graph is going upwards. Yeah. So there is no real root. There is no roots. So yeah, you are right. You can say that it's always positive. Furthest from the starting point. At what time? So now how are you going to find the time when it's furthest from the starting point?
It would be, so basically, the position, it just means that the hovercraft, it will keep moving further and further from where it started. So that it just means the answer is t equals 5. Because 5 would be the furthest point.
Good. Makes sense. Right, so basically what he's saying is that, see this velocity function, he factored it out and he showed that this is always an increasing function. So basically, if you try to sketch this function here, good analysis, that's excellent. So what he has done was, he said this, right? I didn't think of it in that way, but very good. I was actually looking at differentiating this now. And wait a minute, if I differentiate this, I'm still going to get the velocity. And if I differentiate this, set it equal to 0, I won't be able to solve. Yeah, so this would be the, I would have came to the same conclusion. You beat me to it, but very good. Right, so now we're starting at 18. What he's saying is that we're starting at 18 and this thing just keeps on increasing because this is always positive. So obviously the furthest point will be at 5. So you need to substitute 5 in, you still got to substitute 5 inside this function, the position function, all right? Makes sense? You got to substitute 5 in the position function because this is velocity time. We need to substitute 5 in the position function. So if I try to find s prime t here, I'm going to get
Wait,
v
mister,
of
how
t.
is it always positive? Are we gonna solve for
No,
the...
he completed the square. He completed the square,
Yeah, I
basically.
get that. But then afterwards, what do we do to
Yeah,
see
yes.
if it's positive?
It doesn't matter what value of t you substitute here. Very good
Yeah.
question. It doesn't matter what value of t you substitute here. It's always going to give you a 0.
Okay.
And then if you add 2, you only got
Yeah,
2.
okay. Yeah,
And then if
got
you
you.
multiply by 3, you'll always get positive. So it's
Yes.
always an
It's
increasing
always
function.
positive. Yes,
Yeah.
okay.
So now if I find the derivative and set it equal to 0, obviously I won't be able to solve any roots. There is no real roots here. So no answer here. So I would have came back to no real solution because if I try to solve this, find the derivative of this, I'm going to come back to the velocity function. If I set the velocity function equal to 0, I won't be able to solve this equation, all right? So 3t squared minus 12t plus 18 is equal to 0. T squared minus 4t plus 6 is equal to 0. And I wouldn't have be able to solve this. So I would have said t minus 2 all squared plus 2 is equal to 0. So basically what he's doing is trying to complete the square here. All right. So how we got this? So basically what he did was he said t squared minus 4t plus something squared minus the same thing squared plus 6 is equal to 0. So automatically the first 3 terms becomes a perfect square. So that's t minus 2 all squared. That's minus 4 plus 6 is plus 2. And now if you try to solve this equation, you can't solve it because you're getting t minus 2 all squared is equal to negative 2. Okay? So that's why we're saying no real solution. So the furthest point is at furthest point is at t is equal to 5. And now you substitute 5 inside the position function. Okay? Good, Mason. So S of 5 now is equal to 5 cubed minus 6 into 5 squared plus 18 times 5 plus 10. Right, so this 5 cubed is 125 minus 150, isn't? 25 times 6. 18 times 5 is 90 plus 10. So you got 100 and that's minus 25, 75.
Yes.
Right, good. Excellent, guys. Right. Let's look at the next one. On a certain day, the temperature outside a house from 6 a.m. to 6 p.m. So basically 12 hours, right? So 0, 6 a.m. is times 0, 6 p.m. is at time t equals 12, is modeled by the function. This is a function, degrees Fahrenheit, where t is measured in hours. Find the average temperature outside the house between 9 a.m. and 3 p.m. So what do we want? We want the average value of function, right? Right, guys? Don't we want the average? When they say average temperature outside the house, we want the average value of the function, all right? So the average value of function is 1 over, but we want it between 3 and 9, okay? From 9 a.m. to 3 p.m. So 9 minus 3, integral from 3 to 9 of t, which is 65 plus 10 sine pi by 12 t dt. And now you know how to integrate this function. If you want to integrate this function, make sure your calculator is on radians mode because you're working with trigonometry. So that's 1 over 6. Integral of 65 is just 65t plus 10. Integral of sine is cos. Derivative of cos is negative sine. So it's negative cos, right? Integral of sine is negative cos pi by 12 t divided by pi by 12, right? And from 3 to 9, right? So I'm not going to do all this, work out these things. This is elementary stuff, basic stuff. I'm just going to put it into the calculator function and get the answer, right? So
74.
you're getting what? 74
74. We're the blue
degrees
equation.
Fahrenheit. Yeah, the whole thing. Yeah, 74
Yeah,
degrees
that's fine.
Fahrenheit. Yeah, 74 degrees Fahrenheit. Anyone knows what's the conversion from degree Fahrenheit to Celsius? I think it's 4 over 9 times the Fahrenheit
So
plus
it's
32,
32 plus 9 over 5.
9 over
Wait,
5.
no, it
Yeah,
can't be 5 over 5. Is it? Wait, is
9
that
over 5 will
Celsius?
make
One
it bigger.
sec.
I think it's 4 over 9.
Yeah, it should be 4 over 9.
Yeah, I think that's the calculation. Degrees Celsius is basically, I think it's 4 over 9.
It's Fahrenheit minus 32 times 5 over 9.
Come again.
So
Fahrenheit.
Fahrenheit minus 32
Fahrenheit 74
times
minus.
5 over 9.
Okay. So times 5 over 9. What's this answer here? So we know the answer in degrees Celsius. So we know how hot it is. See, it's an application problem. It has to make sense. What's the answer here, guys? 74 minus
23.3. 23.3 repeated.
23 degrees Celsius. Let's just keep it like that. Okay.
Okay.
Mister, is this the final problem?
No. We just wanted the answer in terms of degree Fahrenheit. That's it. That's the answer.
I know,
74.
I'm
No.
saying-
We got two more. But quick. Because oh no, this here might take long. All right, let's just do, let's solve much faster now. Thank you. Let's look at B. At what time between 9 a.m. and 3 p.m. does the temperature equal the average value? The temperature, what's the average value? 74, right?
Yeah,
Correct?
I think.
So we want f of C temperature. So not f of t, I wouldn't say f of t. Okay, let's just say f of t is equal to f of average value. We already got the average value, which is 74, right? And what's f of t? 65 plus 10 sine pi by 12 t. So basically just solving for, what are you solving for here? You're solving for basically, 1 second. There was a t here, pi by 12 t, yeah. You are now solving for 74 minus 65. You're solving for t, so easy. So what is 74 minus 65? That is 9, right? 9, you're going to divide it by 10. The sine pi by 12 t. And then you're going to say t pi by 12 t is equal to sine inverse 9 out of 10 right? And then you're going to divide both sides by pi by 12. So t is equal to, let's work that out. Shift sign. Sine inverse 0.9. Make sure your calculator is on radians measure, okay? Right now it's on radians measure, pi by 12. Shift pi over 12. I'm getting 4.28. Okay, so after 4.28 hours, are we good, guys? That's it. It's easy. That wasn't difficult.
Mr. So you just got the normal ft function and you solved for t, right?
Yeah, it's just solving an equation.
Easy,
Yeah.
easy.
Yeah, obviously you need to solve for equation. That's why we are doing these types of questions. Application problems, you got to do have an understanding of the entire course. Right, so let's look at this. The function R of t models the rate in gallons per hour. Right, so what is this? This is already the rate function. So if you want the volume, you got to integrate this rate, correct? At which water flows into the tank. T equals 0
Mister, if we
corresponds
want
to node.
gallons, we integrate this.
If you want the volume,
Oh, yeah, because it's
you're gonna
already in
integrate
per
that.
hour. Okay,
Yeah.
yeah.
what is the average rate? What is the average rate of water flow into the tank from t equals 0 to t equals 4? How are you going to do that? Average value of function. Whenever they say average rate, you're looking at average. This is a rate function, isn't? This is a rate function. The average value of function. Rate. What is rate? It's a function. So average value of function. Are we good, guys? What's the average value of function? 1 over 4 minus 0 integral of, guys, I'm not going to integrate this. Please someone put this on to the calculator.
I got it.
0 to 4, 200 plus 50t. What's the answer here?
Hold on. Let me integrate this real quick.
Yeah, I want the full answer. I don't want that only.
Mr. I got 300.
Exactly 300.
Yeah.
Oh yeah, 300
300 what? What's the unit of measurement? It's going to be average rate of water.
Pascal or
It's gonna
No,
be
yeah,
gallons
Pascal.
per hour, Mister.
Yeah, gallons per
Right,
hour.
gallons per hour.
Yes. Gallons per hour.
Oh,
Because
no,
remember, you're
it's
dividing it by time
rate.
here.
Yeah.
Yeah,
Yep.
it's still because they're saying what's the average rate of water flow. So the average rate of water flow is 300 gallons per hour. Good. What is the average rate of change? Now, this is different now, all right? Average rate of change, okay? Of the water flow from t equals
So we
0 to
integrate
t.
it again.
No. Why are you going to integrate from 0 to 4 again? Integrate what?
Integrate the new. So it's gonna be 25t squared plus 200t, and we integrate that. No.
Why would you want to integrate?
No,
This is
no,
already
but
giving
they
you a
want the
volume.
average rate of changes one.
Yeah, average rate
Oh,
of
okay.
change.
Okay. So okay,
Look,
got
look,
you.
average.
That's something else.
Yeah, this is something else.
Completely
Average
different.
rate of change is the same thing. How do you calculate an average in calculus? F of B minus F of A over B minus
Fundamental
A.
theorem.
Over B minus A,
Fundamental
yeah.
theorem.
Yeah. Average rate. What we used to call it, average gradient. Remember?
Yes.
Average rate of change. That's the average rate of change will be R of t. We need the function first, isn't we on the original function? So this is R of t. So I'm going to call it V of B minus V of A over B minus A. Because if I integrate the rate, I will get volume, right? Remember, V of t is equal to integral of R of t dt. Okay. So now what was R of t? R of t was 200 plus 50t, correct? So what's V of t?
Mister, isn't this
200t.
just R of t minus R of t? Isn't this just like the f of b minus f of a?
So what is your original function? This is the rate function. This is the derivative.
What?
Isn't? Think about it. Isn't that a derivative?
No, that is the rate function.
This is the function R of t models the rate. What is the average rate of change? Ah, man. Yeah, I'm confusing stuff here.
Wait, mister, can't we just say that the average rate of change is the same thing as the slope? Just to make
Yeah,
it
it
easier,
is.
because
Yeah.
so we're trying to find
Yeah,
the
yeah.
derivative
Yeah.
of the rate of water flow, right?
Yeah. So
Yeah,
basically,
so we
yeah.
obtain
So
the derivative
So it's
of
50.
this function.
we
No, it
already
can't be.
have this. We already have this. So
Yeah.
we're saying R of Miss is right. Sorry about that. So that's R of B minus R of A over B minus A. So what's R of B? Substituting R of 4 minus R of 0 over 4 minus 0. Yeah, it's like your derivative, yes. What is this? What's R of 4? Guys, substitute 4 inside here. You get 400. R of 0 is 200. Correct?
Yes, yes.
Divided by?
It's 50. Divided by 4, which is 50.
Yeah, it's the exact same thing. You could have just obtained the derivative.
Yeah.
Yeah. If you find the
50.
derivative, yes. So basically they're asking, explain
No,
the
but it's
difference in
asking
meaning.
from 0 to 4.
Okay, so explain the difference in meaning between your answers in A and B. What is A? This is 50. What does the 50 over here mean? The
That's
50
the
over
amount of water going in each hour.
yeah, after
Afternoon, yeah.
the amount of water
No, it
going
can't
at
be.
each hour.
Yeah, it is, yeah.
So the amount of water, it was already 200 first, and then now you're after each hour, after no, what is the difference between these two now? What's the meaning? The first one represents an average value of a function, because we had to integrate that and solve, right? The second one represents the derivative, isn't? So
Yeah.
it's basically it's just basically R of t, R prime t. We got 50.
Yes.
What's the meaning between A and B then? This 50 over here represents how
Isn't it?
fast
Can you go up one sec?
the
Isn't
flow.
this other one supposed to be gallons per hour squared? Because we integrated something that was in gallons per hour.
This is gallons per hour
So
squared.
this
here
one, this 50 is gallons per
yes,
hour. The other one is
squared.
gallons per hour squared. No, the other one is gallons per hour squared.
No, this
Because
is
we
gallons.
integrated gallons per hour, mister.
Yeah, we integrated
base,
gallons per hour.
so
Correct.
it becomes gallons per hour, 300 gallons per hour squared.
No.
Because
But you're dividing. If you integrate gallons per hour, you get gallons. You're taking the volume and then you're dividing it by that time again. So this is right, gallons per hour. But now this is already gallons per hour.
yeah.
This is already
And we're
gallons per
dividing
hour
by
and
time
dividing.
again.
So this is
Per
gallons per
hour,
hour
so it's
squared. Yeah.
per hour squared. Okay.
Okay, so that's the difference. So this here represents the rate at which the water is increasing. Increasing rate of change, isn't? It's a rate of change of. This here represents the double derivative, correct? The change in the rate is B, and A represents the average, correct? The average rate of change. Are we good? Average rate of water flow. Just don't say average rate of change, then you're looking at this one here. Change in the rate. A represents the average. A represents the average rate per hour. Average rate per hour that the water is flowing into the tank. Are we good, guys? It's two different units of measurement, okay?
Mm-hmm. Sir, how many more questions are there?
Just one question and we're
Okay.
done.
Okay.
Because now this is a question involving tables. We got to know how to use tables to solve, right? Use the data in the table to estimate R prime 3, okay? Show the computation that leads to your answer and indicate units of measure. Now, see, the rate at which water is being pumped into the tank is modeled by the differentiable function R of t, right? So again, we don't have the function, we just have values evaluated at these different hours, right? So it's like the same as the previous problem. It's just that they didn't give us a function, they just gave us time values and the actual values here. That's why I wanted to do both these problems. Use the data in the table to estimate R prime 3. Now, how are you going to find R prime 3? How do you find R prime x? Let's look at the formula. You remember the first principles formula? R prime x is limit as h approaches 0, R of x plus h minus R of x over x plus h minus x. In other words, divided by h. First principles, all right? So now, if I'm trying to calculate R prime 3, it's going to be approximately equal to, I think we did it in differentials. R prime 3 will be, let's make h, increase h by 1, all right? Be R of 4 minus R of 3 divided by 4 minus 3, okay? Because we are approximating. Because they said what? They said must estimate R prime 3. How are you going to find R prime 3? If I find the difference between these two, if I find the average, if I average this two, the slope at 3, how are you going to find the slope at 3? How are you going to find the slope at 3? You have to take the difference, 5.1 minus 4.2 divided by 4 minus 3. Okay, those are coordinates. So what's the answer here? Still approximately equal to 5.1 minus 4.2 divided by 1. So that's it. What's the answer, guys?
It's 0.9.
0.9. All right. Any other way to do it? We can also approximate it like this. Why only those two values? Why not? We can also take R of, we can also take 4 and 2. Why not take 4 and 2? I want to see if the answers come out like close. Or, so 3 is in the center. Let me try here now. Let me try one before and one after, right? So let me try R prime, R of 4 minus R of 2, but now divided by 4 minus 2. Right, so what is it? R of 4 is 5.1 minus R of 2 is 3.1 divided by 2. I'm getting 1 because 2 divided by 2 isn't. Are we good, guys? So to estimate R prime 3, I wouldn't take the value evaluated at 3, okay? I would actually go and take something one before and one after, because we kind of like estimating it. All right. I wouldn't go with this answer. I would go with this answer, but you can see both of them are very close to each other because it's still on the increasing line. You can see all these points are increasing, increasing, increasing. So it's an increasing function, right? Right, guys? Let's look at the next
Yeah.
one, B. Use a left Riemann sum with the 5 sub-intervals indicated by the table to approximate. How would you approximate this? See, you must use a Riemann sum to approximate this. So integral 0 to 5 of r of t dt, which is basically equal to sigma. We're going to take each of these values and multiply it by the width. So, but now left endpoint Riemann sum, left Riemann sum says you must start from the left. So 0, 1, 2, 3, 4. We're going to end off at 4 and multiply those two out, multiply each of those coordinates out, all right? So 0 to 5 of we're going to go from 0 to 4, right? Those are the 5. And if they say right Riemann sum, then you're going to start from 1 to 5, okay? Are we good?
Yeah.
So we're going to multiply r of Tn. No, let's use I as a counter. Why am I using this? I equals 0 to 4, right? Times delta t. And what's the width? The width is just 1. You can see the width 1 minus 0, 2 minus 1. The width is equal widths. I'm just going to multiply that out. So the first value was, what is the width? R of T naught times 1. Remember, the delta T is just equals to 1. How we got that? The width, delta T is the width. Right, you can see you're counting 0, 1, 2, 3, 4. R of T naught times delta T. Delta T is just 1, so I'm going to leave that out, right? So that is just 1, so leave it out. It's not going to affect the answer. And you just summing up all these values, then R of T naught plus R of evaluated at T1 dot 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 plus R of T 4. Right, so you're just summing up for the left endpoints. So you're summing up these 4 values, 2.0, 2.4, that's 4.8, then 3.1. 4.8 plus
Okay, but Mr.
3.1.
Where did the if we're multiplying by delta t, where did the time go? Shouldn't we do like 0 times 2 and then 1 plus 1 times 2.4 and then 2 times 3.1 and then you
No, but
adding the
no. What is delta T?
the change of t, which is 1. So it doesn't
Yeah,
matter, right? Okay.
yeah, it doesn't matter because I just made that thing
Uh,
disappear. The delta
okay.
T is just 1, yeah.
So it's just the sum
Steps
of
of 1
r,
sort.
yeah, r of t,
Yeah,
okay.
yeah, just doing shortcut here. So what I'm getting is 12.1 here, okay? Final answer, 12.1 for the left endpoints.
Mm.
12.1, what? Gallons, because that is rate of water flow. Yeah. Now, next one. The function a of t 0 to t of r of x dx represents the total amount of water that has been pumped into the tank by time t. Is a of t concave up or concave down on the interval 2 to 4? From 2 to 4, what's happening? Is it concave up or concave down? How we know?
Mister, here if we are allowed a graphing calculator, we just put it in the graphing calculator, right?
No. I'm going to explain this
Yes.
concave up and
No,
concave down.
no. I'm saying if this question is like allowed in, we are allowed to use the graphing calculator, just put
Why?
it in the
Why?
graph.
Why you want to make life complicated? No need to use
Easier.
graphing calculator. It's not. It's easy to solve this problem because what does concave up means? Concave up means is increasing
Yes, increasing.
at an increasing rate. The rate must be increasing. So I'm just gonna look at this. We only want from 2
Wait,
to
Mr.
4,
How
right?
did you get 12.1?
What did you get?
I got
Maybe I made a mistake.
16.8.
Did you multiply anything? I just added
No.
them up.
Yeah,
I
same.
added.
See, 2 plus 2 is 4,
Oh
plus
no,
3
I
is
forgot. I forgot to
7.
add. I forgot to add the 5.1. Sorry
Yeah.
about that. 16.1.
16.8 gallons.
16.8 gallons. Thanks. Right. So this question here for C, the function A of t represents the total amount of water that is pumped into the tank. Is A of t concave up or concave down? So look at the rates from 2 to 4. What's happening from 2 to 3? So what's the average from 2 to 3? So we want to look at what the rate is from 2 to 3. So rate from 2 to 3. So that's 4.2 minus 3.1 divided by 3 minus 1. What's the answer here? 0.
Wait, why 3
1.1.
minus 1?
Yeah, 3 minus 2.
3 minus
Not-
2. So it's 0. 1.1.
Yeah, 1.1. And the second rate, rate 1, a rate from 2 to 3, all right?
Now we want 3 to 4.
Yeah.
Okay.
And then you can check whether it's increasing or decreasing. Then you can
Yeah.
check is concave up, is it speeding or is it slowing down? This is the rate from 2 to 3. Then the rate from 3 to 4, right? No. Oh, yeah, from 3 to 4. So 5.1 minus 4.2 divided by 4 minus 3. What's the rate here? 0.9. Isn't?
Yeah, 0.9.
3.1. So it's basically, it was increasing from 2 to 4. Is it concave up or concave down? Should be concave down now.
Yeah, from 2 to 4, it's 1. The difference is 1. But 5.1 minus 3.1 is 2. All over 2 is 1.
Because see,
So
over
it's
here,
decreasing.
so see what happened was initially from here to there, it was 0.4. I'm looking at the differences, okay? So consider the difference. It was 0.4, then it was from there to there, it was 0.7.
Yeah.
The difference here is 0.9, sorry, 1.1. Difference here is 1.1. And then from there to there, the difference is 0.9. And then from
Yeah.
there to there, the difference is. So it's concave down then.
Yeah. It's
How do I explain this? From 2 to 3 is concave up, and from 3 to 4 is concave down. There has to be like an inflection point somewhere where it is changing. Isn't? There has to be an inflection point. So what did they say? Give a reason for your answer. Is A of t concave up or concave down? It's concave down.
It's concave down. It's like a negative quadratic kind of.
No, concave up. You see, it
No,
was going like this,
it's
then it
going,
changed.
yeah, exactly.
Yeah, it changed. So they changed it kind of like slowing down now.
Yeah.
You see, it was
No, but
the
it's
flow
still
rate
going
was
okay,
increasing,
yeah.
increasing.
It's decreasing.
The flow rate
but
was
yeah.
increasing from 0 to the flow rate was increasing from 0 to 3, and then after 3 it started to slow down,
Start
isn't?
decreasing. Yeah.
So I would say from 2 to 3, from 2 to 3, concave up, and then from 3 to 4, concave down. Possible inflection point at t is equal to 3, isn't it?
Wait, what's an inflection point again, mister?
Where the concavity changes, it
Okay,
speeds up to
yeah,
speeds down.
yeah.
Yeah, slows down. It was speeding up. The flow rate was increasing, and then so the flow rate was increasing. It was accelerating, right? And then after that, it started to slow
It
down.
started slowing down. So the turning point or inflection point was likely at 3, t equals 3.
Okay, let's see. Let me
Yeah.
explain this in terms of the graph. In terms of the graph, it was doing this. It was doing this, right? And then now eventually it started slowing down like this. So that's the inflection point. It was on the concave up cycle, and now it's concave down. You understand?
Mm-hmm. Yes.
The flow rate of water. So there's possibly at 3, that's what's happening. Because see, between 2 and 3 is increasing, and then like between 3 and 4,
After 3, it
becomes
started
smaller.
decreasing less. Yeah, a little
Yeah.
less.
So that's what I'm saying. The flow rate started decreasing. Right,
Mhm.
good. Find the average rate in hundreds of gallons per hour at which the water was pumped into the tank over the interval 2 to 5.
We
How are
use
you
the
going to do
average
this?
value function or
How are you going to find the average? How are you going to use the average value function?
oh yeah, we don't have a function.
Okay, let's see. C,
No.
D. I'm going to say, that's the thing about these tables, because you see the function is not given. So we need to go and figure out the function, all right? So we're going to say integral from 2 to 5. We want to evaluate this, all right? Integral from 2 to 5 of r of t dt, okay? Yeah, so basically average value of function. What they say? Find the average rate. Yeah, we want the average rate. Yeah, so it is the average value of function. We want the average rate in 100
Well,
gallons
so
per hour.
what function do we have for the rate?
Yes,
We don't have.
that's where the problem is. So it's going to be 1 over. Yeah, that's a problem. So we want to find average value of rate. 1 second.
Mister, could we use first principle and say no, but that's a derivative. That's not integral.
Yeah, we can't. We have to use some area formulas. Yeah, 1 second.
Okay.
Average rate or average value of function 1 over 5 minus 2, right? So we got a problem with 2 to 5, is it? What did we do before from 2 to 5? For 2 to 5, what did we do before? What did we do from 0 to 5 before? We used 0 to 5. What did we do? We used the left endpoint, right endpoint, right? We use the Riemann sum to evaluate 0 to 5, right? So we're going to do the same here. Makes sense. But now we need to find left endpoint and right endpoints here. Okay.
So we do two Riemann sums, a left and a right.
Yeah.
Okay.
So left endpoint, Riemann sum will give me you summing up from 2 to 5, right? 2, 3, 4, 5. So you're just going to sum up 3.1, 4.2, 5.1. Okay. You're only going to sum up 3 values, 2 to 5. Because the width is already, and then for the right endpoints, you're going to sum up from 3 to 5. Okay. Make sense, guys? For the left endpoint Riemann sum, you're going to sum up from 2 to 4. And for the right endpoint, you're going to sum up from 3 to 5. So left endpoint
But
Riemann sum.
we use the R of t values, right?
Yeah, R of t
Yeah,
values.
okay.
Because
Okay.
you remember Riemann sum is like an integration.
Yeah.
So 3.1 plus 4.2 plus 5.1. What's the answer here? That is 0.234. That is 7 and 5. That's 12.
12.4.
12.4. And the right endpoint Riemann sum? In other words, area from the right. It's going to be 4.2 plus 5.1 plus 5.9. What are we getting? This is 6 and 5. That's 11, right? Put 0.1 here.
I
You
got
get 6.
15.2, mister.
15.2.
Yeah.
So we're going to take the midpoint. So what's the midpoint now? Midpoint of these areas. So the area midpoint will give you 12.4 plus 15.2 divided by 2. So you average it out and then you can approximate this. Okay, what's the answer?
Mm.
So remember, this is area
Let me
from
see.
the left, that's area from the right. So now average rate will be 1/3. 1/3 area from right, area left plus area right divided by 2. What's the answer? 1/6. What's the answer here?
Mister, I got 1 sec. 13.8.
This value or the
Yes.
final value,
Yeah, final. No, that value, the average, midpoint.
and then 13.8. Let's take 1/3 of 13.8.
Equal to
1/3 of 13.8, getting 4.6
0.6. Yeah.
gallons per hour.
Okay.
Yeah, because this is a volume, all right? And that dividing it by time. Isn't it? Because remember, when you're finding the integral of a rate, you're getting volume and you're dividing it by time. So it's going to be gallons per hour. Yeah. All right, guys.
Wow.
Thank you. One
Thank you,
second.
mister.
Rizwan.
Yeah.
Oh,
Mizar,
boy.
did you hear what happened?
Dude,